In this next lesson of Homework Packet 6.1, we're going to take a look at transformations again, but instead of shifting up and down, we're going to look at horizontal shifts, which deal with shifting a function left and right. You can see that the information here about how to shift a function left and right, it looks similar but not identical to what it looked like to move something up and down. I am adding or subtracting a c value, but there's a key difference. In the vertical shifts, it was f of x plus c, the plus c on the outside. Notice here that it's f of x plus c, and the plus c is directly on the x value inside of the parentheses. That actually has fairly significant consequences or implications when we look at it. We'll see what we mean by that when we look at our first example. But the other thing you need to notice here is this, that left and right is counterintuitive. Notice here that if I want to move left, I actually add. Even though we know that left is usually a negative direction, I actually have to add the value that I want to move left. And here, if I want to move right, I'm actually subtracting that value of c. So left and right are counterintuitive. To move left, I add. To move right, I subtract. So again, pay attention to that and know that horizontal shifting is counterintuitive. It's opposite of what we expect. So let's look at our first example, a nice simple linear equation right here. F of x equals 2/3 x minus 4. So I'm going to go down to -4, my y-intercept, and 2/3. I'm going to do the graphing of the original fairly quickly because we've done graphing enough, and this lesson isn't meant to teach graphing, it's meant to teach shifting. So if you need to review graphing any of these types of equations, please consult the videos from section 4 or unit 4 in which we learned to graph these different types of equations. So -4 and then 2/3 up 2 over 3 up 2 over 3. So here's the graph of my original function. We're supposed to take this and shift it left 6 units. We're supposed to shift it left 6 units. From an equation standpoint, here's what we have to do. We saw on the previous slide that if we shift left, we have to think counterintuitively. Shifting left actually means I add the value. But remember, we saw that the value was added directly onto the x. Here's what it ends up looking like. Wherever I have an x, I'm going to replace that x with, in parentheses, an x plus 6. And then we have -4. So notice how instead of adding 6 to the end of the equation like we did to shift it up and down, I am adding it directly onto the x value in parentheses. I'm adding those parentheses in to show that that plus 6 only goes onto the x. Now, I do want to simplify here. So I'm going to distribute this 2/3 in. So that's going to be f of x is equal to 2/3 x, and let's see, 2/3 times 6, I believe, is a 4. So 2/3 x plus 4, and then I still have my -4. What we'll notice is those 4's cancel out, and we're left with f of x is equal to 2/3 x. So here is the equation, shifted left 6 units. What does my new graph look like, shifted left 6 units? You'll notice here in this new equation that I have no y-intercept. That means my y-intercept is at 0 now. Notice here that the original equation, x-intercept, if I move to the left, 1, 2, 3, 4, 5, 6, that takes me to the 0. Furthermore, my slope hasn't changed at all, so up 2 over 3, up 2 over 3, or down 2 over 3, and now I can draw this line. You could also look at it from the perspective of this y-intercept down here, move it 1, 2, 3, 4, 5, 6 units to the left, and there it matches up nicely with that line. Okay? So I'm going to label this one right here as 0, -4, and this one here as 6, negative 4. And also my y-intercept here was at 6, 0. Now it's at 0, 0. Both of them have been shifted to the left 6 units. Let's now look at it in the context of an exponential equation. I see that my horizontal asymptote is down at negative 4, so I'm going to draw that line. Okay. And if I work it out, I find that my x-intercept is equal to 0.980. So 0.980 is right here. And if I work it out, again, I'm not going to work through that stuff because that's things that you've already learned how to do. The y-intercept, find the y-intercept by plugging 0 in for x. I find that my y-intercept is 0, negative 1. So I'm going to put a dot here. I see that this base multiplier is greater than 1, so that matches what I see right here and here on my x and y intercepts. Let me label that 0, negative 1, and 0.980. Okay, now it says that it wants us to take and move this to the right 3 units. So what we saw was that if we want to move something to the right, we have to think counterintuitively, we're actually going to have to subtract. But we subtract directly onto the x. So here's what it looks like. G of x is equal to 3 times 1.34 to the power of, directly onto the x, I'm going to do x minus 3. So that's shifting it to the right 3 units, and then minus 4. One of the nice things about doing this with exponential equations is there's no simplification necessary. That is a completely legitimate equation right there. There's no simplification or manipulation algebraically that I need to do. The question is, what does this look like shifted to the right 6 units? Well, I'm sorry, 3 units. All I have to do is take the x and the y intercepts and shift them to the right 3. So I'm going to take this y-intercept here and go 1, 2, 3 to the right. I'm going to take this x-intercept here, go 1, 2, 3 to the right. My horizontal asymptote won't change at all because it's not moving up or down, it's simply moving left or right. And that right there is what my new exponential equation will look like, shifted to the right. The new coordinate point here is going to be 3, negative 1, and the new coordinate point here is going to be 3.980. I added 3 to both x values of the x and y intercepts. So there's my new equation shifted to the right 3 units. The next equation we want to see this in the context of is a quadratic equation. I've got a quadratic here in vertex form, and I see that my vertex is at the point 3, 5. So I'm going to go over to 3 and up to 5. Now I know that because there's a negative in front, that from here it's going to open down. My parabola is going to open down, which means I'm going to have x-intercepts. If you work it out, to find the x-intercepts, you plug 0 in for y. You'll find that the x-intercepts are at 0.76 and 5.24. So I'm going to do something like that and something a little more smooth than that. There we go. So labeling this is at the point 3.5. This right here is at the point 0.760, and this right here is at the point 5.240. So our goal is to shift this to the left 6 units. Left 6 units. So that is f of x is equal to negative. Now, how am I going to work this? I need to shift it left 6 units. Again, counterintuitively means I'm going to add 6, not subtract. I'm going to add 6 in order to move it to the left. But I add it directly onto the x. So in the location of that x, I'm going to write x plus 6. Just like that. And then plus 5. Now, realistically, these parentheses around the x plus 6 don't matter because it's not being squared. It's not having anything else being done to it. So realistically what I'm going to do is I'm going to rewrite this as f of x equals negative, if I have x plus 6 minus 3, that's really just x plus 3 squared plus 5. So here's my new equation shifted to the left 6 units. What does this look like on my graph over here? If I take each of these 3 points that I know and shift it to the left 6, my vertex moves over here to negative 3, 5. This x-intercept here goes to, let's see, we need to do 0.76, right, minus 6, that becomes negative 2, 3, 4, negative 5.24. And then 5.25 shifted to the left 6 units, I believe is negative 0.67 or 0.76. So shifted to the left, here's what my new parabola looks like. Labeling this, that's negative 5.240, and this is negative 0.760. So there's the equation shifted left, and now the graph shifted to the left. The last one we want to take a look at is a radical equation, where the x is underneath the square root. So we remember the starting point is hk, the values here and here. We have to think opposite on the h, so it's actually negative 2, positive 4. That starting point is negative 2, 4. I've put my point right here. And I know that because it's a negative in front, that I am going to go down and to the right instead of up and to the right. Now, working out x and y intercepts, we find that our y-intercept is at 2.59. That's right here. And we find that our x-intercept is way out here at 10, 11, 12, 13, 14. Way out there. We don't need to worry about that one too much since it's off the graph. But what does this look like? Looks something like that, where our starting point is at negative 2, 4, and the y-intercept is at 0, 2.59. Again, to work that out, to find the y-intercept, plug 0 in for x. So what does my new equation look like shifted to the right 7 units? So I've got negative square root of, what do I have to do to that x? If I want to shift it to the right, I subtract and then 7 units, so it's minus 7. So the x gets replaced with an x minus 7, and I still have the plus 2 under the square root, and then I have that plus 4 on the outside. So simplifying that, p of x is equal to negative square root of x. Let's see, what is negative 7 plus 2? That would be a negative 5. So it's negative square root of x minus 5 plus 4. Here is the new equation that has been shifted to the right 7 units. Graphically, what does that look like? Take each point and shift it 1, 2, 3, 4, 5, 6, 7 to the right. 1, 2, 3, 4, 5, 6, 7 to the right. And here is my new equation shifted to the right 7 units. Because it's to the right 7 units, I can take and adjust my coordinates here to 5, 4, and 7, 2.59. And there it is, the radical new equation being shifted to the left, to the right, and then the equation, or the graph of the equation on the coordinate plane shifted as well.